Hello, in this session we will talk about what is a view in a database. This is Hassan Mir from 02protraining.com. So view is defined as a result set of a stored query. So let's talk in detail on what does that mean, and in the next session we will talk about materialized views. And materialized view is defined as a database object that contains the results of a query. So we'll try to understand the difference between a view and a materialized view. So in this session we will talk about a view. In the next session we will take the discussion to the materialized view, and we will try to understand the cost and benefit of a view versus materialized view. Let's try to understand difference between a view and a materialized view. This is a table. It has columns and rows, so rows keep on increasing as you keep on adding data to the table. It's important to understand that tables are not physical structures, they are logical structures as well. The data is physically stored, for the sake of discussion, in database files. There is not one-to-one relationship between database files and tables in most databases like Oracle. How data is stored in the database files, this is not really a problem for us. It's more of a problem for the database management system. So all the complexity is under the hood. So for us, data is neatly stored in tables. As far as we are concerned, we create tables, we insert data in it, and we can drop tables. How the data is stored in the actual database files is the headache for the database management system, and that was the whole idea behind relational databases, that all the complexity will be absorbed by the systems, and for the users everything will be simple. When tables get very large and complex and we want faster retrieval of data with complex queries, then we can create indexes. Indexes are another object in the database just like tables, and indexes store the address where the actual records are located in the database file based on certain attributes. For example, if we are doing lots of queries on department number, show us all the employees that belong to this department and that department, we can create index on department. So this way, first system will talk to the index. When you do this query again, then system will talk to the index, and index will tell the system, okay, go into this location to get all these records that belong to certain department. So this way query would be faster as opposed to doing a full table scan and system going and reading the whole table from top to bottom and trying to find out all the employees belonging to department 10. So you can do all sorts of queries against the base table. So this is the actual table, and index will be used if you are doing any query that involves the column on which index has been created. Indexes could be created on multiple columns as well, but that is not the topic for this session. So let's say you are doing this query again and again, show us all the employees where department is 10. You're not really interested in phone number and other attributes. You're only interested in the ID of the person and the name, for example. So you can create a view. Rather than doing this query again and again, select ID and name from employee table where department number is 10, you can simply create a view and you can give a name to the view. In this case, employee 10, let's say, is the name. A view could be created on a base table for different purposes. For example, you can call the base table with a different name by using a view, and although synonym object is there for that purpose, but view could be used for that purpose as well. If a base table reflects detailed data, a view could be created to reflect summarization of the detailed data, and a view could be created to display a subset of data in the table in terms of both columns or rows. For example, if table has 20 columns, in a view you can simply display 10 of those that you're interested in, and you can also filter on rows like we did in our example. And also, if you have data in multiple tables, related data, and you do not want to issue join statement again and again, you can simply create a view to reflect the join of data that is residing in multiple tables. So in our example, we created a view on the base table employee that reflects only ID and name columns and only the data for department 10 employees. Once I have created a view on the base table, I can do a query directly on the view rather than doing a query on the underlying table. So here the two queries are equivalent. Select star from employee 10 view, or select ID and name columns from employee table where department 10 department number is 10. So this query here is already reflected in the view itself. So I do not need to write this filter again and again. So I can select everything from this view. So whenever you touch this view in terms of retrieving data, so whenever you do a query on this view, underlying query is run as well. So there could be performance issues. By creating a view, you're not gaining any performance as such. So you are basically asking the database management system to automatically run the query, which is part of the view's definition, which is this query in our case. So when you do select star from employee 10, this query is automatically run behind the scenes, and any index on the base table that will assist in performance of this query will be used. So in this case, index 1 that was created on department number column on the base table will be used, even though you are querying the view itself, not the base table. So any index that is relevant will be used, even though that index is on the base table.